Howdy folks, chapter 6 is going to be about something called differential equations. Differential equations are just equations, pretty easy, but they've got x's, y's, and then some kind of derivatives of y. So you're just mixing up normal variables with derivatives in the same equation. Up here in blue and purple, we have a whole bunch of examples. Now, whether you have the derivatives separate or with a number in front of it or even mixed in with another variable, it doesn't matter. They're just mixed anywhere. And when I say it includes x's, y's, and derivatives of y, it doesn't have to include an x value. It doesn't even have to include a y value. It could just say y prime equals 4x. Okay? It is just a way of mixing all of these together, and you see these quite often. In fact, so much so, one of the semester courses in calculus in college is solving just differential equations. In blue, we have what's known as the first degree differential equations, mainly because if you have a derivative there, it's just a first derivative. If your highest derivative is a second derivative, we call that a second degree differential equation. A third degree differential equation would have a third derivative, etc., etc. You get the point. So now, why do we have these differential equations? I gotta be honest. Sometimes you just don't know the function of different things. How do we always know the function? Sometimes instead of actually knowing the function of a value, you can actually see how it's changing. And doesn't a derivative tell you how something's changing? So maybe you start off with something that has the change or describes how something's changing, and you have to work backwards to find the function. We just integrate, right? Well, that could work, and that's going to be a big part of this. First, I just want to bring you up to date with some terminology here. Differential equation, we got one over on the left, and we have some possible solutions to it on the right. So what that means is, could I actually plug these in to find if this is a solution for the differential equation there? It's really this simple. See that first one, y equals x cubed? The derivative of x cubed is 3x squared. All we need to do is go to your differential equation and just substitute in y and y prime everywhere they present themselves. So right here we have the equation. I know that y prime is 3x squared. I know that y was equal to x cubed. Is this a true statement? Is it the exact same on the left-hand side as it is on the right-hand side? I have 3x cubed minus 2x cubed. Curious, that might be x cubed. Is that the same as x cubed times e to the x? No, I don't think so. That means we found out that this is not a solution. It is not going to be a solution of this particular differential equation. Take a look at the second example. If I take the derivative of that second possible solution I have here, I get cosine. When I plug these in, are those the same values on each side of that equation? Do you think 4 cosine minus 2 sine equals that exponential? I don't think so. That's not going to be a solution. No chance. Forget about it. But the next two, look at those derivatives and see what you can do with that. Look at that derivative there for our third example. If we take our derivative and plug it in for y prime, and we take the original and plug it in for y, I think you'll find something that might look familiar. Watch how. These values, when multiplied together, are going to look really similar. We have a positive 2x squared and a negative 2x squared times e to the x. And then we're left with x cubed, e to the x equaling itself. Well, that lets me know right there, this is a solution. Now, ladies and gentlemen, this is a very nice solution, but that doesn't mean that we're done or we've found all the answers. For if we take the derivative of that last one right here with the extra minus 5x squared, and we plug in the derivative and the original, it turns out negative 10x squared and positive 10x squared equals 0. Positive 2x squared e to the x and negative 2x squared e to the x equals 0. Oh my gosh, it's the same exact thing again. This is also a solution. Yes. There is more than one possible solution to some of these differential equations. So just if you get one, it's like when you take an integral, you can find a whole family of possible functions that might have existed from that one differential equation.